Now, in this part of the video, we'll talk about transmural pressure. Transmural pressure is a pressure gradient across any tube or sphere. It is calculated as inside pressure minus outside pressure. This pressure determines whether the sphere will expand or collapse. If the transmural pressure is positive, the sphere distends. If negative or zero, the sphere collapses. Of course, it depends on the structure of the sphere. There are three important transmural pressures in the lung system which you should know: transpulmonary pressure, transthoracic pressure, and transrespiratory pressure. Let us first see what is transpulmonary pressure. It is very important to note that the lung is very elastic tissue. If I expose the lung of this person to conditions outside of his chest cavity, the lung will shrink and collapse. This means within the chest wall, the lung and alveoli are held open because you know that in vivo or in life we cannot completely collapse the lungs. You know that even after a long breath, no matter how hard we try, still 1,200 mL of air remains in the lungs. This volume is called residual volume. So what is the force which holds the lungs and alveoli open within the chest cavity? Actually, this force is transpulmonary pressure, the pressure across the wall of the lung. This is the first of the three types of transmural pressures we will discuss. In order to understand how this pressure acts on a lung's wall and holds it open, I give you an example. Let us see how pressure acts on the inner surface of the balloon wall. Suppose the balloon has a gas pressure of 500 millimeters of mercury. In this case, 500 millimeters of mercury pressure within the balloon pushes the inner surface of balloon and tries to distend it. So transpulmonary pressure on the lung system acts somewhat like this. Let me draw three lungs to explain how negative, positive, and zero transpulmonary pressure act on the lung's wall. Please note that I enlarged the pleural space. These are alveoli. First, you have to keep in your mind this equation which says transpulmonary pressure is equal to alveolar pressure minus intrapleural pressure. First, let's talk about transpulmonary pressure at FRC. It is very important to know that at FRC, the alveolar pressure is 0 and the pleural pressure is minus 5 cm water. Transpulmonary pressure will be the pressure across the lungs wall. It is alveolar pressure, which is 0, minus negative 5, which is intrapleural pressure. So this equals plus 5 because subtracting a negative turns into an additional problem. Transpulmonary pressure of positive 5 is a net force distending the lung, which in turn keeps the alveoli open. This was about transpulmonary pressure, which again is the force that holds the lung and alveoli open even after maximal expiration. Now let's talk about negative transpulmonary pressure. Suppose I inject an air in the intrapleural space of the second lung and make the intrapleural pressure positive. Let us say to plus 2 cm water. Putting values in our equation, in this case, transpulmonary pressure will be 0, which is alveolar pressure, minus positive 2, which is the intrapleural pressure now. It equals negative 2. It is extremely important to know that if transpulmonary pressure is negative, it is a net force trying to deflate the lung. In a third lung, suppose I make a puncture on the chest wall of the patient and make the pleural cavity in direct communication with atmospheric air. Because the pleural pressure is negative and outside is considered to be 0, the air rushes into the pleural space until the intrapleural pressure equalizes with atmospheric pressure and also becomes 0. If you calculate the transpulmonary pressure in this lung, it will be alveolar pressure, which is 0, minus pleural pressure, which is also 0, and we get 0. The alveolar pressure and intrapleural pressure become equal. In this situation, there would be no pressure holding the lung open and it would collapse. In a clinical practice, in case of pneumothorax due to penetrating injury at the chest wall, the pleural space will be in direct communication with atmospheric. Atmospheric pressure is 0 and the intrapleural pressure is minus 5 cm water at FRC. The negative intrapleural pressure sucks the atmospheric air until it equalizes with atmospheric pressure. When you calculate the transpulmonary pressure, in this case it will be 0. If the transpulmonary pressure is 0, the lung collapses. This is the reason why the lung collapses in case of pneumothorax. I hope now you also understand that why the lung collapses if I have it outside of normal physiologic conditions. Let us talk about transthoracic pressure, the second of our 3 transmural pressures. Transthoracic pressure is the pressure difference between the pleural space and the body's surface. Please note that I have enlarged pleural space in this diagram. If we calculate transthoracic pressure at FRC, it would be -5, that is the pleural pressure, minus the pressure on a body surface, 0 atmospheric pressure, and we get -5 transthoracic pressure. Again, it is very important to know that if the transmural pressure is a negative, it is a net force trying to deflate the structure, the chest in our case. This concludes that at FRC the chest is slightly sprung inward by negative transthoracic pressure. But if I take the lungs and pleural out of the chest cavity and the chest will be isolated, it springs outward because I removed the force which holds the chest slightly deflated. To sum it up, you have to note that at FRC the lung is distended by the positive transpulmonary pressure, whereas at the same time the chest is slightly deflated because of the negative transthoracic pressure. Both forces are equal, so at FRC there is no any distending or collapsing force. This is very important to know. The third and final important transmural pressure is transrespiratory pressure. Transrespiratory pressure is the pressure difference between the alveolar pressure and the atmospheric pressure. It is a pressure across the whole chest wall, pleural, and lung. Let us calculate it at FRC. At FRC, the alveolar pressure is 0. 0 minus 0 atmospheric pressure equals 0. This concludes at FRC there is not any force on lung system to expand or deflate the chest and lung. This is why the FRC is considered neutral or equilibrium state of the respiratory system.